Hello, everybody. So here we go. We're thinking about dolphins here, and the textbook says that this path of the dolphin jump can be modeled by this quadratic function, where f of x, the output, is the height in meters, so the y value is the height in meters, and the x value would be the horizontal distance in meters. Okay, and then we're given this function, and I think that my first reaction is, these numbers are intense. Like there's like what is this? Negative 0.211202 and 1.80127. Are these coefficients arrived at? Like how do you get these is our question. Remember, these coefficients have names. If you remember back to this slide here, a is the number that is in front or multiplying the x squared, b is the one multiplying the x, and c is the one without any x being multiplied to it. So we're thinking about this. How do we get the a, b, and c values for this quadratic? Well, as the picture suggests, we're going to go to Desmos right here. So I want to show you, I want you just to go to a new tab, and I want you to go desmos.com. I want to show you this from the beginning. If you click on the graphing calculator here, you'll get to this page. Now, to put a visual in, it's actually really easy. You go to the image button right here, and then it lets you select from any image on your laptop. Where is the dolphin one? Is it this guy? Yes, it is. Okay. And what it does is just plops it right here. Now, I kind of want to make it like where in the picture, like the dolphin was right around the zero, and then it kind of goes, like I guess it starts here and then heads towards zero here. So I'm wondering this. Um, can I move this? Yes, I can. Look at that. All right, cool. Now, another thing I like to do when I'm on Desmos that I don't know if many people know is I want to go to the settings. I want to make this go up by ones. I want to make the y values go up by ones here. This, for some reason, just helps my brain make sense of the visual a little bit more. I think it's a good idea. So I'm going to get it so that the dolphin nose is kind of at zero, zero. Close enough. Okay, cool. So now it's like, all right, I know that my parabola should go like this. Like I could try to guess if I wanted to. No, it should be looking down, or I should do a reflection on it. Okay, I should maybe move it to the side. And I hope right now you're yelling at your screen saying, Mr. K, please do not make us guess on this. Please, that would just be terrible and really not a good use of our time. Yeah, I could try, but you know what? Desmos can do this for us in a way that's much more accurate than we could ever do. What I want you to do here is add a table, and I want you to come up with some points right here. So I'm going to mark where the dolphin nose is. That's where I want the path to be tracking. So for this first dolphin, I have a nose at 0, comma 0 here. That's where I'm putting this nose here. Now, this guy right here, I think I have 1 is the x value of this point. And then, I don't know, 1.85, 1.8, 1.6. Yeah, okay. Here, I want to make this easier to see. There we go. Okay, so I have these guys right here, and the third dolphin looks like it's 2.5 as the x value, and then 3.2 maybe? 3.2. Okay, great. And then maybe this fourth dolphin here looks like 4.3-ish, um, and 3.9, we'll say. Okay, cool. Now I could do them all, but I want to show you how Desmos uses this system that's called quadratic regression to help us find our equation. So now that I have my x1 and my y1 values, the points of this path, I'm going to let Desmos do all the work. Now take a look at what I'm typing here. y1 squiggly a x1 squared. So I'm just going to let Desmos do the work by putting in basically a standard form, which I just want to show you from the slide is right here. I'm just going to put this in ax squared plus bx plus c. But I'm not going to forget something. I'm not going to forget to put ax1 squared. If I forget to do that, this will not work. Bx1 plus c right here. Now, look at this. Right now, it has made a quadratic that has perfectly fit these points. And right down here, you'll see in this box, parameters. That's the name that we give to coefficients. Their parameters for this parabola don't change. These are the a values, the b value, and the c value that fit these 4 points. Okay, cool. So I'm going to take a screenshot of this just for my records. And I'm gonna go back to class kick and paste it in here. Control C, delete, boom, and hopefully there it is. Okay, so I have right now, and it's slightly different because I put the picture in slightly differently, and that's okay. But because of this, Desmos quadratic regression, I can write an equation that matches the dolphin path pretty precisely right here. Instead of a, I could write negative 0.207 x squared, and I could write plus 1.8 x, and then my c value here is, which I would move that a little bit. I'm going to do that. My c value here is plus 0.002. 0. That is a 0.002. So this is my function right here that will kind of match the path of the dolphins. We're going to try to use this function to answer questions about the dolphin path here. Thank you very much, everybody.